Welcome to today's webinar on whole site delivery with Amazon CloudFront. First, let me introduce today's presenters. Today's presenters will be Nihar Vihani, Senior Product Manager of CloudFront, Irakli Nidrashvili, Director of Engineering at NPR, and Stephen Evans, Head of Digital Technology at the Toronto Star. I'm going to hand this over to Nihar now to begin the presentation.
Great. Thank you, Jared. So as Jared said, my name is Nihar Vihani. I'm a Senior Product Manager with Amazon CloudFront. And myself and Stephen and Irakli would like to talk to you today about whole site delivery using Amazon CloudFront. So in terms of the agenda for today, I'll be presenting first and talk about what is whole site delivery and how should we think about whole site delivery, why use CloudFront for whole site delivery, and I'll also do a demo and show you how you can easily configure a CloudFront distribution and set up a distribution to deliver your entire website using CloudFront. And then we'll leave a good amount of time for both of our customer presenters, who I'm really excited to have us join here today, both Stephen and Irakli, to talk about their use cases and how they're using CloudFront to deliver their entire website. So what is whole site delivery? Before we start sort of thinking about whole site delivery, I just wanted to take a quick minute and talk about what is CloudFront. CloudFront is a content delivery service. We have global edge locations, and CloudFront also integrates with other AWS services to make it really easy for you to deliver your content to end users around the world with low latency and high throughput. And whole site delivery is really an example use case of CloudFront, where you can deliver both static and dynamic content on your website using a single CloudFront distribution. So let's look at an example of a personalized website. So this is the Amazon.com homepage, a screenshot. And if you look at the top left, the first circle there, it says Jared's Amazon.com. So that's an example of personalized content or dynamic content. If I go to this page, it will say Nihar's Amazon.com. So each viewer or each visitor to this page gets a personalized experience. And then if you look at the modern family picture in the middle of the page, that bigger circle, that's an example of static content. So both Jared and I, when we go to this page, we get to see the exact same static image. So the point really, the point of this slide really is that most modern websites today are a mixture of dynamic and static content. And typically, you'll see these websites have an architecture that looks something like this. So in this architecture diagram, you see the end users or the viewers are using their browsers to get to download two different types of content. So they use up top, you see www.example.com as the first domain name that points to the star.php path. And that request from the browser goes directly to the dynamic origin servers, which in this case happen to be an elastic load balancer with EC2 instances, or it could be even a custom origin running outside of AWS. And then from the browsers, these viewers make a second request, or the browser makes a second request to cdn.example.com, which downloads content for the star.jpg path, which are static images on this website. And this request goes first to a CloudFront distribution, and the CloudFront distribution can serve those images if they're already in its cache, or go to the Amazon S3 bucket, or again, a custom origin if the objects are not already in cache. So what's happening here is, while this website is getting the advantage of CloudFront as a CDN for the static content, for dynamic content, these viewers are having to go directly to the origin servers. So as a result, there are both performance as well as scalability considerations that you, as the website owner, have to keep in mind. From a performance perspective, if you have a global set of viewers who are downloading, who are going directly to the origin servers, then some of your viewers will be further away from the origin, and will need to travel a long distance to download that dynamic content. And from a scalability perspective, if this website or this application gets really popular, you would also have to think hard about how you can scale your or have your origin server set up so that it can scale for that demand. So if you change this picture slightly, what I've done here is now the end users are going to the CloudFront Edge location first with the www.example.com domain name to download all content on this website, both dynamic and static content. And their CloudFront distribution is configured to go to that same dynamic origin servers for the start.php path and the same static origin servers for the start.jpg path. But from a end user's perspective, they are downloading everything from the CDN and getting the benefits of low performance and scalability when this application does become popular. So when you think about an architecture like that, there are some questions that come to mind. And when I've talked to customers and looked at websites along with customers, some of these questions have turned into themes. And I think of some of these themes as myths. So the first thing that comes up quite a bit, the first myth, is none of my HTML pages are cacheable. So there, when I sit down with the customer and look at their website architectures, we often discover that many pages on a website are cacheable. A good example here is search results pages. So specifically, right now I'm in Seattle. So let's say I go to a mobile application. I'm searching for, during lunchtime, I'm searching for restaurants in downtown Seattle. Now, chances are there are other folks going to that same application and searching for for the same keywords. So unless the set of restaurants or the set of results changing dynamically or for every user, that page can be cached so you can get the benefit of low performance delivery as well as scalability for your end users. The second myth that I hear about is my HTML pages are customized, so those cannot be cached. And here, CloudFront has released a couple of features, over the past few months, specifically cookies and query string parameters that can be used to customize web pages, and still get the benefits of caching at the edge location. A specific example is local weather pages. So again, going along with the same theme, I'm in downtown Seattle. I'm checking the weather for the downtown Seattle area, and I put in the zip code, and someone else could be in one of our nearby cities, for instance, Bellevue, and checking the weather there. And both the users are going to the exact same web page, but based on the zip code that they have as part of their cookie or query string, they could get a customized version of that page, which is cached for a few seconds or a few minutes at a time. If you think about this specific use case, the local weather pages, a great example of scalability here is when there are weather alerts, and your website or your application starts to get a lot of traffic because everyone wants to view those weather alerts, and that's where having these pages cached at the CDN edge can really help offload, help you handle that scale and offload that traffic from your origin servers. And the last thing that I hear about is my pages are personalized and unique for each user, so a CDN won't be useful there. And while that may be the case in some instances, there are a lot of use cases where the network and path optimization features that CloudFront has built into our network can help speed up the delivery of truly dynamic pages or personalized pages like the example we saw for the Amazon.com homepage. And we'll talk about some of these network and path optimizations later on as we discuss CloudFront features. So before diving into why use CloudFront for whole site delivery, I wanted to highlight a few whole site delivery use cases, what we see customers do today with CloudFront and when delivering their entire websites via CloudFront. So news is a popular example, and we have Stephen from Toronto Star Newspapers who will be speaking with you later today in this session about their use case. as well as Aracli and what they did when they were delivering the entire website. Weather is an example I already mentioned. There are sports scores, travel updates, stock quotes. These are all examples of dynamic content where the content is being updated very frequently, yet you can get the benefits of low latency as well as scalability when using a CDN like CloudFront to cache those results. Advertising is another example where using cookies and query strings, you can customize the ads that you serve to your end users on the publisher's websites. So why use CloudFront for whole site delivery? So the key point that I'd like to make here is to not think of CloudFront as a niche product that can only help your static objects or the static portions of your website. If you look at this list, CloudFront can help make your web applications, if you're delivering your entire application via CloudFront, faster, scale better, more available, easier to manage, and cost less. And these are by no means niche benefits or niche properties. These apply to both the dynamic and the static portions of your website. So let's dive deeper into each one of these. So CloudFront can help make your applications faster. The way I think about this is in terms of a simple equation. Long distance plus poor network leads to slow load times. So let me talk a little bit more about what I mean there. If you have a global user base, some of your users will be connecting to your origin servers over a long network path. That in itself results in long round trip times, just because of the sheer distance that they are away from the origin servers. When you combine that with a poor performing network with high packet loss, that can really result in slow load times for your dynamic content or your pages that you're serving directly from your origin servers. The way CloudFront helps here is by changing both of the input variables of this equation. CloudFront turns the long distance into a short distance and the poor network path into an optimized network, which leads to, as a result, fast load times for your website and a better experience for your users. So specifically on short distances, that comes from CloudFront's global network of edge locations. We have 40 edge locations around the globe today, including Seoul, which we very recently added within the last few weeks. And this network helps offload terminate your end users' connections at one of these edge locations and help you help your end users connect over a shorter distance or a shorter network path to a CloudFront edge location, and then CloudFront manages the connection back to the origin servers, which is the longer haul, depending on where your end users are. And on the optimized network paths, improving the network connectivity, CloudFront is focused on both the network paths here, from the end users to the CloudFront edge location, as well as from the edge location back to the origin servers. So you see this image, it's just a stripped down version of the architecture diagram you saw earlier. Specifically from the end users to CloudFront edge locations, the low latency comes from the fact that the edge locations are close to the end users, as well as CloudFront has implemented several TCP/IP window sizing and other optimizations that allow delivery of data faster between the edge location and the end users. That, combined with the persistent connections as well as the monitored network paths that CloudFront uses to connect back to the origin servers, can result in your dynamic pages being delivered faster to your end users than going via CloudFront than going to the origin servers directly. CloudFront can also make your web applications scale better. And the scalability comes from three factors. First, you can continue to cache your static content at the edge. That's a use case that has been there since the beginning of CloudFront, since we launched the service. In addition, CloudFront utilizes persistent connections and collapses multiple requests for a particular object coming at the same time back to a single or a few requests back to the origin. So this really helps you offload the load from your origin to the edge and let the edge location network that CloudFront has handle the scale when your applications become popular. A specific example here, you see the image at the top right of the Mars rover Curiosity that landed on Mars in August of 2012. The NASA Jet Propulsion Laboratory, JPL guys, they used AWS to host the website experience for the Mars lander and used CloudFront to deliver their entire website to their end users. And they really needed a solution that could help scale for them because as new images from Mars arrived and were stored in an S3 bucket, which was the origin for CloudFront, those images they needed a scalable system to deliver those images to the end users to be able to handle the traffic that came in to view those images. So they decided to deliver their entire website, both dynamic and the static image portions of the site, via CloudFront. CloudFront can make your applications more available. So an example here is Toronto Star newspapers, and I won't go into too much detail, but because Stephen will talk to you about the availability benefits that they got when they started using CloudFront. But these benefits really come from the fact that CloudFront is architected for high availability. CloudFront has a network of locations around the globe, and we're architected in a way that even if one location is either out of service or needs to be turned off for some reason, your end users don't see any impact because they get routed to other edge locations or the edge location that's the next best location for them automatically. So a high availability and that level of redundancy is already built into the CloudFront network. In addition, and CloudFront can serve your content even when your origin is unavailable. And this is a lesser-known feature of CloudFront, but it's really beneficial from an availability perspective because let's say you have an object cached at one of the CloudFront edge locations for 3 hours, and after the 3 hours have passed, CloudFront is unable to reach your origin servers because the origin is unavailable. CloudFront will continue to serve the stale content so that the end users at least get to download that content and to keep your website available. CloudFront also has an availability SLA that's available, that's up on our website that you can take a look at. CloudFront can make your applications easier to manage. The ease of management comes from what's true across all Amazon Web Services, and that's the self-service sign-up and easy configuration via the APIs or the management console. But in addition to that, what customers have also told us is that they don't need to write any custom code to use CloudFront. A specific customer there is Earth Networks, who delivers their desktop, web, and mobile applications, their WeatherBug application via CloudFront, and they use a lot of CloudFront's whole site delivery features. And what they've said, what they've told us is they found it really easy to configure CloudFront to deliver these applications without needing to write any custom code, which they had to do with other CDN providers. In addition, CloudFront also has features such as multiple origin servers and cache behaviors, which we'll look into a little bit more detail when we look at the demo, that make it easy for you to put together an architecture that we saw earlier where you have a single domain name, www.example.com, pointing to both your dynamic and static origin servers by defining multiple rules within CloudFront to go to specific origin servers for different types of content. And finally, CloudFront can help make your applications costless. There are a couple of points that I'd like to zoom in on here. First, CloudFront charges the same for dynamic content as it does for static content delivery. And this is a really important point because you'll find that a lot of the other providers will put a premium in terms of price when you want to deliver dynamic content. CloudFront, from a pricing perspective, treats dynamic and static content the same. Second, earlier this year, we announced preferential pricing between AWS origin servers and CloudFront edge locations. So when CloudFront makes origin fetches and goes to either an Amazon EC2 instance or an Amazon S3 bucket, EC2 and S3 will charge a rate that is lower than the regular internet data transfer rates when the request is coming from CloudFront. This rate can be as low as up to 83% discount than the internet data transfer rates. CloudFront is also less expensive than the AWS data transfer rates for delivery over 10 terabytes per month. So if you look at the public rates listed on the AWS data transfer page, and on the CloudFront page, you'll notice that CloudFront is less expensive than data transfer out of EC2 and S3 to the internet when you're delivering over 10 terabytes each month. And CloudFront does offer reserve capacity pricing if you have large volumes of delivery each month that you are able to make a minimum commitment for. So at this point, let's switch to do a quick demo. So what I have here is a very bare bones, simple application. It's a Twitter application that pulls the top 3 or top 5 trending hashtags that are trending at the top on Twitter right now. Uses the Twitter API to do that. And so that's the example. The chart you see is the example of dynamic content on this page. And the static content is simply the AWS logo that you see towards the bottom of the page. So switching over to the AWS Management Console, I wanted to show you what's going on behind the scenes. So here I have a CloudFront distribution that I've created. The domain name is D3957. It's a long and not a very customer-friendly name. So the first thing I did is created a CNAME to this distribution, called it summit.cloudfrontdemo.com. This is the same demo that I did at an AWS Summit earlier this month. And for this distribution, what I've done is I've created multiple origin servers. So I have 3 different origin servers configured here: origin dot, origin 2 dot, and an S3 bucket. And let's see how CloudFront is pointing to these different origin servers. So if you look at the cache behaviors, you'll see that star.html and star.jpg, CloudFront is being instructed to go to origin 2 dot to fetch these files. And CloudFront will go to the S3 folder or S3 bucket to fetch the star.png or the images. And then for everything else, CloudFront is instructed to go to origin dot. And that everything else in this case is the live Twitter feed data that you see, which is a Beanstalk application running on an EC2 instance, and that is responding with JSON files with the top trending hashtags every second. And to quickly, what's going on behind the scenes and why this is so interesting is some of the things that we talked about in terms of the network and path optimizations that CloudFront has built are really coming into play here in fetching this dynamic content every second, because the end users are not needing to make new TCP connections every time, because the CloudFront Edge location already has persistent connections it's utilizing with the origin servers, the origin dot and the origin 2 dot, as well as the S3 bucket. In addition, if this happens, if this all of a sudden becomes the most popular application on the internet, to handle the scale, since all of this data is coming from a CloudFront Edge location, it's the Edge locations that will handle the scale and send very few requests back to the origin server, so you don't need to worry about scaling those origin servers that you've configured here. So that's the quick demo that I wanted to give. And at this point, let's switch back to the presentation. And I'd like to hand over to Stephen, who will walk you through how Toronto Star uses CloudFront for whole site delivery.
Well, thanks, Nihar. It's great to be with everybody this afternoon or this morning, depending on what part of the continent or world you're in. I wanted to give you a quick overview of some of the things we've been doing at the Toronto Star with CloudFront and whole site delivery. So if you want to go to the next slide. So I wanted to provide everyone with a little bit of context around around who the Toronto Star are and what we're doing. So we are the largest daily newspaper in Canada. Our focus is on the Metro Toronto area. To give you some context there, Toronto is about 5.5 million people in the metro area, and our weekly circulation is about over 2 million print copies of the newspaper. So we have a big impact in the Toronto area. In terms of our website, according to ComScore, we have about 3.3 million monthly unique visitors, so a fairly large website. In terms of our organization, I'm part of a small in-house digital group within the Toronto Star, the larger print organization. There are about 30 of us in the digital group, and we have a small digital technology group of about 10 people, and we're supported by both external vendors and our corporate IT folks as well. We really try to run as a startup, so we're quite agile, and our main focus is trying to deliver value as opposed to putting process in the way of building cool websites and getting stuff done. Our tech stack is a mixed stack. We have a lot of Java, quite a lot of PHP, and a little bit of Ruby, and that's an evolving process. And we recently relaunched our flagship site, thestar.com, on AWS in general and CloudFront in particular at the end of January of this year. Next slide, please. So a little bit about how we selected AWS. I was hired by thestar.com, or by the Star, in January of 2012 as a result of an internal restructuring, and I had a mandate to not only evaluate hosting infrastructure technology, content management technology, but also to build out a new technology team. So when I joined, it was myself and one developer, and as I said, we're about 10 folks now, and that's been an evolving process. So one of my first jobs, responsibilities, was to look at cloud hosting options. So we went through an evaluation process, including AWS, Rackspace, and others, looking at capabilities and cost and other benefits. And then we ran a short pilot phase where we ran some smaller websites on various hosting providers. But it was quite clear to us pretty quickly that Amazon Web Services was the best choice in terms of both value and capability and flexibility. So we began a migration into the Amazon cloud. So that process started in the spring of 2012. We began with a very small blog site that we had running on WordPress, but we were able to test things like EC2 and load balancing and RDS and even CloudFront at that time, but really we were focused on static assets at that time. Over 2012, we migrated our larger sites one at a time onto Amazon, our automotive vertical, our local directory vertical. These sites have increasing amounts of traffic, so we're able to test scalability and our ability to operate within the Amazon cloud. This whole process really culminated when we migrated the Star.com in January of this year, and that's quite a different infrastructure and architecture, so there was a lot of interesting engineering decisions to be made there, one of which was to move forward with a whole site delivery using CloudFront approach, which I'll talk to you in a lot more detail about in the coming slides. Next slide, please. So a little bit about the choice of CloudFront. As I mentioned, we had already made a decision to use Amazon Web Services, so we knew about CloudFront and we knew it was an option. But when we were launching the Star.com, we really wanted to take a harder look at the various options. So we did take a hard look at Akamai as a potential option, and we did some evaluation there. But given the CloudFront model, where there's really no risk to trying the service, we're really paying as we go, we were able to run a pretty detailed proof of concept within CloudFront. And what we discovered through that proof of concept is that CloudFront really met all of our priority feature requirements. So we did some performance evaluation as well using load testing, and decided to move forward with CloudFront. One of the things we like the most about CloudFront is ease of configuration, and I'll show you that in quite a lot of detail. As Nihar has shown you, that we can use custom behaviors, and they're very easy to configure. As well, CloudFront have demonstrated that they have an aggressive roadmap and they continue to add functionality. So we're pretty confident that some of the new things that we need will be delivered in the future. So that gives us a vote of confidence there. And finally, I mentioned this in terms of pricing flexibility, but from a cost perspective and from a pay-as-you-go perspective, CloudFront has clearly got advantages over some of its competitors. Next slide, please. So I wanted to give you a little bit about the overall architecture of the star.com. So you can see that CloudFront is in front of this entire architecture, and that is for both static and dynamic content. But the origin server and the origin infrastructure is a pretty important piece of this. So this is our star.com content management system. It's a platform called Adobe CQ5, and it's really a multi-tier architecture, but without a relational database behind it. So that's a bit unique. In terms of the tiers, I'll start from the bottom of your screen. We have the author tier, and this is really where our editorial team does their work in terms of managing both the content of the star.com as well as the content workflow and layout of the star.com in terms of sections and other parts of the hierarchy. We have a redundant infrastructure there, so we have a standby author server in a different availability zone, and then those two author servers will publish content out to 6 publisher servers that span 3 different availability zones in a VPC. The publish servers are really responsible for serving requests, assembling content, and synchronizing between what the end user sees and what the editors are working on. Then we have the dispatcher tier, which is really a reverse proxy caching tier, much like something like Varnish or HA Proxy. That is sort of customized to the Adobe CQ5 environment to manage caching rules on the origin side, and all of that is behind an elastic load balancer. So we have both great edge caching with CloudFront as well as a highly redundant, fault-tolerant origin server using Adobe CQ5. Next slide, please. So this slide is really to take you through some of our approaches and some of the things we discovered in terms of best practices for whole site delivery using CloudFront. So the first really important bullet point is cache everything possible, and there's a few things you can do to avoid invalidating that edge cache as much as possible. Now, CloudFront will serve dynamic content, so it's not verboten to create dynamic content and have dynamic content served by the server, but our approach is really to try to make sure things are cacheable and take the load off of that dynamic capability and push it down to the client side. So the first rule to enable that is to try to avoid writing any server-side cookies. This allows us to actually make sure all of the core pages are cached, and then on the client side, you can do things to read and write cookies, and I'll give you a more detailed example of that in the next slide or one of the next slides. The other thing is we try to avoid passing query strings where they're not absolutely necessary. In the case of things like search, they are necessary and they can be cached, but we try to avoid that when we can. I mentioned this, but CloudFront gives you very fine-grained control over your caching rules. So we have a set of 19 different behaviors that dictate which parts of the star.com site are cached using which rules and what time to live, and I'll show you that in some detail in the coming slides. We used distributed load testing to validate performance against the multiple edge locations. There are some complexities in doing this based on the way DNS works with CloudFront, and if you are looking to do load testing against CloudFront, I encourage you to speak directly to the folks at Amazon about the best practices for doing that, because it's not, you can't assume that things work the way you would expect them to work when you're not using a CDN. As I mentioned, we use a single origin as opposed to Nihar's example where you can have separate origins for things like static and dynamic content, and you can even assemble different many origins into one CloudFront edge location or CloudFront distribution. We have a single origin that serves both dynamic and static content, but it's scaled out and fault tolerant. We're also planning a disaster recovery architecture that will leverage CloudFront, which will then take our origin into a different Amazon region in case of DR needs. Okay, next slide, please. So now we're into a bit of JavaScript code. I'll assume that people are at least vaguely familiar with JavaScript, but what we're really trying to demonstrate here is how we are pushing the processing of cookies from the server side to the client side. So these are a couple of jQuery functions, and the first one is basically setting a cookie that's around font size. So when a user goes to an article on the star.com, there's a button they can press to increase or decrease the size of the fonts on that page. So when they click either of those buttons, it fires an event that's caught by this first jQuery function that will dynamically change the CSS, as well as in the last line of this function, we'll write a cookie with that font size from the client side into the browser, thus avoiding us having to do any dynamic resizing on the server side through reading that cookie. And then the second function just shows how that cookie gets read on load and renders the correct font size for that user based on that cookie that was written on the client side. So we have many other examples of places where we're using client-side cookies in order to maximize our ability to cache those pages in CloudFront. Next slide, please. Okay, so now we're into behaviors, and really behaviors are a set of rules that dictate what content on your site gets cached using what rules. So as I mentioned, we have 19 different behaviors, and this is all of them as we've defined them. The definition of behaviors is really a conversation you need to have with your business stakeholders, and I'll talk a bit more about that later. A thing to keep in mind with the behaviors is they're processed in order. So really what happens is a given URL gets parsed, it gets matched against the first, or attempted to match against the first rule. If it doesn't match the first rule, it moves to the second rule, and so on. So it's really regular expressions in this order, and then if you get through all of these different patterns and you don't match them, you hit your default behavior, which in this case is the default behavior is number 19. So if we go to the next slide, you'll see what that default behavior looks like. So we have the matching pattern, we have the origin, which we can set to either an Amazon load balancer, an S3 bucket, or a custom origin that could be anywhere. We define what protocols we want to support. We define how we're going to handle object caching, either using the origins cache headers or a custom cache header. In this case, it's custom. Our time to live, which our default time to live is 5 minutes. Whether to forward cookies. So if you do not forward cookies, then you're going to have fewer cookie scenarios to cache. So this makes it easier to cache these things, and this is why we're writing cookies client-side. You can define whether to forward query strings. So again, you can forward query strings, but each of those query strings will be cached separately. So you will more quickly invalidate your cache, but in many cases this is a requirement, and I'll show you an example of this later on, etc. Okay, so we'll move to the next behavior. So this is our behavior. This is the behavior rule we use for all of our images. We set up different behaviors for each image type, JPEG, GIF, and PNG, but essentially we're using similar rules for these different types. The same origin, as I mentioned. The key difference you'll notice here is we have a longer time to live. It's a 15-minute time to live because our images are not updated as frequently. We could even potentially, for certain classes of images, define a much longer time to live, and that's going to dramatically improve the cacheability of those images. Next slide, please. Okay, so this is an example of matching a path based on the date. And so what this allows us to do is to customize the time to live, the time that a page is cached for our archives based on the date in the URL. So in this case, we're caching any content from 2010 for 15 minutes. We could potentially, we haven't done this yet, but we could potentially say if content is from 2008 or 2007, cache it for 2 hours because it's very unlikely to have been updated over a long period of time. And that would, again, improve the performance of our site as well as reduce the load on the origin service. Okay, next slide. So this is the final example, and what I'm showing you here is an example of where we are forwarding the query string. So this is our search page, as Nihar mentioned. You can cache search results pages, and it works perfectly well. You're forwarding the query string, and the query string is really a key into the caching of that page. So in this case, our time to live is shorter. It's only 2 minutes long because we want our search results to be refreshed fairly frequently, but it does allow us to cache what is seemingly dynamic, what is dynamic content and what in the past may have been considered uncacheable content. So I think that's the run through of all the behaviors. We go to the next slide. I'll talk a little bit about the success that CloudFront has helped us deliver since we relaunched the star.com. So the graphic here is showing you our performance from the edge using Pingdom. So this is an end user experience response time. So you can see before we relaunched using CloudFront and AWS, our response time was in the 600 millisecond range, and we basically have that after we relaunched on using CloudFront, using AWS, and using Adobe CQ5. So that's the performance side of things. In terms of the reliability and fault tolerance, we had a little bit of a wobble on the day of launch, so that took us down to 99.99% uptime since we relaunched. If you take that day and a half, that first day and a half out of our metrics, we've had 100% uptime since we launched. So that's a combination of factors, but CloudFront plays a large role in that performance. And then in terms of business impact, we've lowered our hosting costs. We've got an improved customer experience, clearly from a more performant, more available site, and there are clear SEO benefits in terms of Google and Bing through faster response time. So this is my last content slide. I just want to leave you with some lessons learned, some things to think about as you're looking at deploying your own CloudFront whole site delivery scenario. There's some constraints you need to be aware of in terms of using a CDN and using CloudFront specifically. So for instance, if you need a custom SSL domain today, that isn't available through CloudFront. I expect it will be available at some point in the future. That is a constraint. If you have scenarios where you need to post forms, you need to think about working around that. Currently, CloudFront supports GET requests, but not put delete requests. So there are workarounds for that, but you want to be thinking about that. And as I mentioned, think hard and fast about writing and reading server-side cookies. Another thing to think about is, as I mentioned, we put a lot of time and effort into making sure our origin is scalable and has its own caching tiers. So CloudFront is great and is a great added cache, improves performance, but it doesn't remove the need for the standard web scale caching stuff and scalability of your origin server. Think about reporting requirements. The ability to get detailed reporting on CloudFront is there, but there isn't a lot in terms of beautiful user interfaces and handy charts and graphs. So you may want to think about what you're going to do about that. And there are some options there that are available. You can talk to Amazon about that. And finally, I mentioned the 19 behaviors. So really, this is a business conversation about how does your site work? What are the expectations of your product owners, of your business folks? What is an acceptable delay in terms of updating content? All of those things need to be encapsulated in the behaviors that you build as you deploy your CloudFront solution. So with that, I think I'm done. And thanks for listening. Feel free to ping me on email or on Twitter, and I'll hand it over to Irakli from NPR. Thank you very much.
Thank you, Stephen. Hello, everybody. My name is Irakli. I lead the technology team at National Public Radio. NPR is a mission-driven multimedia news organization and radio program producer with a headquarters in Washington, D.C., and almost 900 stations all around the United States. Today, I would like to share with you the story of how we successfully scaled our main website, npr.org, to almost 10 times the usual traffic, and consequently were named the fastest news website by an independent study. Next slide, please. So every 4 years, the best athletes in the world get their biggest event. That would be the Olympics. Likewise, we, the techies at the news organizations around the United States, get our biggest event every 4 years, but it's called the presidential election night. This is the night of the most intense news coverage. It's also when the dials on the gauges on our traffic go in the red zones. And a typical news website can get up to 10 times the normal traffic on an election night. For a major news website, which gets a lot of traffic even on a normal day, like npr.org, that means a lot of traffic. Next slide, please. So to give you a sense of what traffic looks like, and this is not the actual data, this is just a depiction of the shape. Traffic is pretty much normal all day on an election day, maybe slightly higher due to the coverage. Then it rapidly starts growing around 6 p.m. Eastern Time as the first results from the closing polling stations start rolling in. Then coverage intensifies, traffic keeps high as the polling stations close through the country until the winner is announced, usually happens around midnight. Next slide, please. So in any scaling effort, the key is to obtain reliable data. Simply put, if you do not measure, you do not know. Any kind of assumptions, no matter how common sense or truthy looking, are to be assumed false until they are proven by empirical data. So from the past experience, we knew that npr.org was going to get a significant traffic spike on the election night. We started preparations early. About a month and a half earlier, we put together a cross-functional team of developers and system administrators. They were charged with the sole task of preparing our system for the traffic spike we expected on the election night. Next slide, please. So in order to measure how much traffic our systems could take, we needed tools to generate large amounts of traffic. We did have an outside firm on retainer that can generate a lot of traffic professionally. And the benefit is that they can really deeply analyze the traffic and generate load in a creative way. But there are two problems with an outside firm doing load testing for you. Number one, such services can be quite expensive. And number two, setup and reporting usually takes some time, can take several days. So bottom line, while third-party load testing is very useful, you also need some way to run a massive distributed load test on your own frequently and on a short notice. In reality, we ended up using the third-party firm twice for the baseline test and after all the optimizations were done. But we also built an in-house tool. To build such tool, we used an open source project as the starting point. It's called EC2 Fleet. And then we made some modifications to customize it for our needs, added some improvements. The end result of our efforts, a distributed load testing tool that runs on EC2s, on a bunch of EC2 servers, is now published on GitHub, and it's licensed under open source MIT license. Next slide, please. So running the test, we quickly found out that when pointing traffic that was about 10 times larger than our normal traffic, we had two major bottlenecks. And keep in mind that as a major news organization, we get a lot of traffic even normally. So the bottlenecks with 10 times the traffic were, one, physical bandwidth of the pipeline that connects our servers to the internet was getting exhausted. And two, our primary data center is on the East Coast, and performance of the load tests run from the West Coast of the United States were significantly, well, relatively, but significantly worse than the ones run from the East Coast. So geography also played a role. What's interesting is that neither of these findings were necessarily obvious without empirical data. Typically, when developers, software engineers optimize for scalability, we tune SQL queries, speed code up, install more servers, do the obvious things. And as you can guess, for the bottlenecks that we had, none of these techniques would work. Adding more servers would not increase the pipeline, and tuning the SQL queries would not fix the geography problem. Next slide, please. So our solution to the problems we identified was what Amazon calls whole site delivery, serving page HTML and assets through content delivery networks, aka CDNs. Content delivery networks are geographically distributed, so they could both serve content from the location nearest to our user, fixing the geography problem, as well as provide a much broader pipeline than what our single data center can handle. As most high-traffic news websites do, we had been serving static assets such as audio, images, CSS, and JavaScript through CDN for years now. But this time we wanted to serve dynamic content such as HTML through CDN as well. While static assets changing frequently, we can cache them for longer times. But the content on election coverage pages of NPR were changing very often, obviously. So we couldn't use the fixed URLs. So how were we going to cache something like that was the big question. Next slide, please. Well, the thing is that we were talking about scalability here, being able to handle large numbers of requests per second. When you're dealing with scalability, caching things even for a very short time helps a lot. If you cache the HTML of your pages even for 30 seconds, how many requests will CDN serve per those 30 seconds that do not go back to your origin? Well, the answer is more, higher the traffic. So it becomes very, very effective to cache your dynamic content even for very short periods of time when you have a lot of traffic. And that's exactly what we wanted to achieve. So we worked with our editorial team and got them to agree that 30-second latency was acceptable even on election night, even for news content. And caching for 30 seconds gave us huge scalability boost, as well as geographic redundancy and uptime. Next slide, please. So as we put our dynamic content, HTML on CDN, we ran into some pitfalls that I would like to share with you. They're very similar to the ones that Stephen described. So for a news website like npr.org, the most effective CDN cache is logicless. Allowing HTML of the rendered pages to be the same for all users maximizes the cache effectiveness, especially considering that we only cache for very short times, 30 seconds to 1 minute. One practical drawback of this, however, is that your backend code cannot be trusted to make any user-specific customizations if you want to maximize your cache effectiveness. If you do need user-specific content, all that logic needs to be put on the client-side code, typically in JavaScript. So the second problem was that our API uses HTTPS. And as Stephen mentioned, you cannot assign a custom domain for now with CloudFront to your HTTPS request, as well as post-put and you cannot make post-put and delete requests. But the capacity that we were able to free from our origin, because CDN was serving so much content, actually gave us enough capacity to scale API, so we had no problems there as well. And third, CDNs are highly geographically distributed systems. When using local caches such as Varnish, common strategy is to expire stale content from cache on demand. So you implement all kinds of rules. If you update your content, you just send a request to Varnish or similar system to expire cache. While CloudFront does have an API that allows you to do that, because CloudFront or any other CDN is geographically distributed, the propagation of that API request and subsequently clearing of cache actually takes long time. Typically, in our experience, it can take more than 15 minutes, which is obviously unacceptable. So you cannot, when using CDN, one thing to keep in mind is that you cannot rely on the same techniques that you would use with local caches like Varnish or any other reverse proxy. Next slide, please. So typically, CDNs are some of the most reliable technology systems that you would employ because they are, by definition, geographically redundant and highly available. That said, no technology is bulletproof, and if you do care about reliability, you should avoid any single point of failure, even CDNs. On the election night, we used 2 CDN providers concurrently, Amazon CloudFront and Akamai. Each one of them served approximately 50% of our traffic, And we had them configured so that if there was any downtime whatsoever, we could flip the DNS switch and point all traffic to the CDN that was up. In reality, neither of the CDNs had any downtime on the election night, but having a redundant system gave us great peace of mind, which is exactly what you want when you expect huge traffic spike during the most important news event of 4 years. Next slide, please. So in summary, election night was a significant success for NPR. It went without a single glitch, and we got a lot of positive feedback regarding how fast and scalable NPR.org felt from the user point of view. We kept the whole site delivery system that we built for election even after the election night. And this, among other optimizations that we used, played significant role in NPR being named the fastest news website in a recent independent study. Well, if you look at the list of the organizations on this chart, these are major news organizations. None of their websites are slow, so this was very prestigious, and we were really stoked to be able to achieve it, which Amazon CloudFront, alongside Akamai, played a huge role in allowing us to do that. So it then should be no surprise that we think whole site delivery through CDN is a great technique, even when used appropriately. Thank you very much, and back to Amazon guys for some Q&A.
Great. Thank you very much, both Stephen and Irakli, for taking the time and presenting today with us. Just a couple of resources that I wanted to point out. You know, there's a lot of great information and documentation available on the CloudFront webpage. So if you just go to aws.amazon.com/CloudFront. And I also wanted to point out we are running short on time today for questions. So we do have office hours coming up in about a month on June 19th at 10 a.m. Pacific. And you can sign up for those office hours. There's a link available on the CloudFront website, the webpage. So just go to aws.amazon.com/CloudFront to sign up for the office hours. Yep, and I'll hand it back over to Jared.
Thank you, Nihar, and thank you, Stephen and Irakli, and thank you all for attending today's webinar. I encourage you to continuously check the webinar section of AWS to see listings of other upcoming webinars, as well as recordings of this webinar, which should be posted in the next 2 weeks. On behalf of Amazon Web Services and our presenters, Nihar, Stephen, and Irakli, I thank you for joining us for our whole site delivery with Amazon CloudFront webinar.